lesson here. So section 413, polynomial functions and multiplicity. So what is multiplicity? So multiplicity is when you find out how many times a zero, or we call them solutions, or a root, occurs in a polynomial. Okay, so what is multiplicity? Well, that's when you find out how many times a zero, that's what you're going to see most of the time. They're going to say find the zeros. Okay, in other words, find the solutions, find the roots. How many times a zero occurs in a polynomial? So maybe you solve for an answer and you get like a 1. Sometimes we say your answer of 1 has multiplicity that's even or it's odd. Even means it bounces, odd means that it goes through. We'll talk about that in a little bit, the very next part. But we're going to figure out how many times a certain number occurs as a solution to a polynomial. Okay? So how many times an answer occurs in a polynomial? That's called multiplicity. Okay? Now, how can you identify multiplicity? There's 2 different ways. Okay? So one way, look at the power assigned to the factor. I know this doesn't make a lot of sense right now, but you'll see them right now in some examples. But look at the power assigned to the factor. Okay? I'm going to put right here, even power equals even multiplicity. And I'm going to use the word mult, M-U-L-T. You don't have to write the whole word multiplicity. Just use M-U-L-T. That's going to mean multiplicity. So an even power means that it has even multiplicity. Odd power is odd multiplicity. Okay? Now, why does that even matter? Well, step 2 is going to explain why it's good to know the multiplicity of these numbers. Okay? So you can identify it by looking at its factored form. Okay? That's one way. The second way is using a graph. With a graph, look at the x-axis. Okay? Any point that passes the x-axis, you're going to look at your graph, and any point where it passes the x-axis or it touches the x-axis, that's considered a 0. Okay? So with the graph, look at the x-axis. Maybe I should add a little bit here. Let me get rid of that period. To find the 0. Okay? So you're going to look to see where it crosses the x-axis or touches the x-axis. And right here I'm going to put in parentheses. If it bounces off, and you'll see this in a picture later, I know it may not make sense right now, but just write it down. If it bounces off, that means it has even multiplicity. If it goes through, then it has odd multiplicity. I know this doesn't sound like a whole lot, but this is kind of like the important part of the lesson today. Okay? So how can you identify multiplicities? There's 2 ways. One of them, they're going to give you an equation, and the equation is going to be factored out for you. And all you have to do is look at the factors and ask yourself, okay, does this factor have a power? And if it does, is it an even power or an odd power? Because if it's an even power, then we say it has even multiplicity. If it has odd power, then we say it has odd multiplicity. Okay? If it's not an equation and they give you a picture, then you're going to look at your picture where the x-axis is, and you're going to look to see where the graph touches the x-axis. And wherever it touches the x-axis, you're going to ask yourself, does it go through it or does it bounce off of it? Because if it bounces off of it, that means it has even multiplicity. That's why it bounced. Okay? If it has odd multiplicity, it's going to go right through it. Okay, and again, this will make a lot more sense once you see some examples. So give me a minute. Here's the last thing that I kind of want to define for us, and then we're going to do some actual problems. What are zeros? And I kind of put them right there. Solutions, roots, okay? These are answers So these are answers found by solving a function. Now we're not going to have to do a lot of that today, okay? But we are going to do something to help us solve, but we're not going to solve big functions. These are answers found by solving a function or the location where a graph touches the x-axis. So again, you can find these in two different ways, right? I mentioned it in the definition above. It can be based on an equation, or you can see it in a graph. Seeing it in a graph is a lot easier, actually, even though graphs look more confusing, but it's actually easier on a graph. Okay? So, we're going to be trying to find zeros, so these solutions, these roots. Okay, we're going to be looking for them. And if they give me an equation, I'm going to find them by solving that equation. If they give me a picture, I'm going to visually look at my x-axis and see where they're at. Okay? So, we'll start off, as usual, simple, right? This doesn't take long. To do these problems does not take long because notice they're already factored for us, so we don't have to really do anything in terms of like setting it up. It's already set up for us, and that's the way it's going to be in your homework. All right? So they're going to want you to find the zeros. Okay? Find the zeros. In other words, set this up so that it's equal to 0. So this is what I'm going to do. Let's do part A really quick. I'm going to write 2x minus 3 x plus 1 equal to 0. This is how I set it up to find my zeros. Now, you guys remember the zero product property we did like a month ago or so, which basically says if you have stuff that's factored out and it's equal to 0, you can set each one of those things equal to 0. In other words, 2 is equal to 0, x minus 3 is equal to 0, x plus 1 is equal to 0. All right, can 2 equal to 0? No, right? So that's not even possible. What's the answer to the one that says x minus 3 equals 0? 3. What about for the next one? X is negative 1. And I'm done, okay? I'm done. I'm not even talking about multiplicity yet, okay? But this is my answer for this problem, and I'm finished. So if they ask you just to find the solutions, this is what you do. So do part B. Try to beat me to it. Okay? But part B is already factored for you. They just want you to find the solutions, find the zeros, find the answers, find the roots. These are all words that mean the same thing. Okay, it's kind of annoying that we have so many of them. But you know, when they tell you to solve, find the solutions, find the answers, find the roots, find the zeros, it means the same thing. Just solve. Now this step that I'm writing right here, you do not have to write. I'm just showing it because this is basically what they're asking you to do. The step that I just wrote, that's what they're asking me to do. Now I'm going to break it apart. X minus 4 equals 0. X plus 2 equals 0. X minus 3 equals 0. So the first one, if I solve it, I get x equals to 4. What's the middle one? Negative 2. What about the last one? 3. So there we go. We got 3 answers. It's going to be negative 2, 3, and 4. I know I'm moving a little fast, but I'm not expecting you guys to have a lot of trouble solving these things. These are things we've done already for a long time ago, so it shouldn't be brand new. Okay? Now, just so you guys know, all of these solutions have odd multiplicity. Okay, multiplicity of 1. They're all odd multiplicity. How do I know? Well, because the ones that I was able to solve, so notice I was able to solve this one right here and this one right here. They came from here. And what are the powers on the outside of the parentheses for x minus 3? Is there a power? Well, there isn't, but there is. What's the number? 1. And that's odd, right? 1 is odd. So we say it has odd multiplicity of 1. But we normally don't say multiplicity 1. We only start at 2 and higher. But you could say it, odd multiplicity of 1. Look at the other answers, negative 2, 3, and 4. They came from here. What are the powers on these parentheses? 1s. So they're odd multiplicities, which means that if I were to graph my graph, I would put little dots at negative 2, 3, and 4 on the x-axis, and the graph would cross through it. How do I know it's going to cross through it? Because if it has odd multiplicity, it goes through. If it has even multiplicity, it'll touch the point and bounce back in the direction it came from. Okay? So you'll see that right now when we get to it. Right now it may not make a lot of sense because we're not doing that. So, here's the first one that we're actually going to talk about, multiplicity. Find the zeros, the solutions, and their multiplicities. Now, when you're solving for multiplicities, you don't have to worry about the powers that are out there. You do have to think about them. Don't forget about them. But when we're solving for it, we're not going to think about the powers. We're just going to look at the factors, right? There's an x squared, x minus 1 cubed, and an x plus 2. The only thing I'm worried about is setting x equal to 0, x minus 1 equal to 0, x plus 2 equal to 0. Now, if you're wondering, well, what happened to the x squared? I don't care. I don't care about that when I'm solving for multiplicity, because x squared has multiplicity of what? It's 2, right? And that would call that an even multiplicity. Why would I say that it's an even multiplicity? Because look at the power on x. It's even. Which one has odd multiplicity? Which factor? The x minus 1. The x minus 1 has odd multiplicity. Also, x plus 2, right? We just can't see it. There's a power of 1 on the x plus 2, isn't there? So that one would have odd multiplicity as well. But let's go ahead and solve. Do I have to do anything to solve x equal to 0? No. What about x minus 1 equal to 0? What do I get? 1. And the other one, I would get x equal to negative 2. Now here's how we write the multiplicity. Okay, ready? Here's my answer. 0 was one of them. Okay? What was the power where I got that x from? 2. So I say 0 multiplicity 2. That means that 0 occurs twice. When I solve this, 0 occurs twice. Like when I look at the graph, you're going to notice it's going to occur 2 times. With multiplicity 2, meaning it's going to touch the 0, it's going to bounce off. You'll see a graph of that coming up in a bit. Okay? So do you guys understand how I got 0 multiplicity 2? So I look at I solved the x squared part. I just wrote x equals 0. And then I solved it, which was 0. Right? I didn't do anything. And then I said, where did this 0 come from? It came from here. What did this look like? X squared. The 2 tells me it's multiplicity. Multiplicity 2. The power is where you find it. Okay? So when I write my next answer of 1, what's the multiplicity on that one? 3, because the answer of 1 came from here. This came from here, the x minus 1, and the power is a 3. So it has multiplicity 3. We could also say that it has odd multiplicity. Now, why would I want to know that it's odd? Because if I had to graph it, knowing that it's odd tells me it goes through. I know 0 is even, right? Multiplicity 2 is even, so it would bounce off. Okay? So my last answer is negative 2. What's the multiplicity on that one? 1. We don't write multiplicity 1, so we just leave it like that. Okay, so there you go. So there's a part B. Right now we're going to do a part B. But remember, the powers that are there in the beginning tell you it's multiplicity. Okay? You don't have to use those powers to solve anything, but they're there so that you can notify the reader, like this one's even, this one's odd, right? So let's look at part B. Again, they've already factored all this stuff for us. I don't have to worry about it, okay? I don't have to worry about it. It's already pre-factored for me. So all I got to do is solve, okay? I just have to solve. So let me go ahead and write this out so that I can solve for it. So the first factor is x. I'm going to set it equal to 0. The next factor is x minus 2. I'm going to set that equal to 0. Remember, I'm ignoring the power of 2 because I'm just talking about multiplicities, okay? And the last one is x plus 1, and I'm going to set that equal to 0. And then I start solving. So x equals 0 is the first thing I'm solving for. But that's done. So good. Finished. X minus 2 equals 0 comes out to x equal to what? To positive 2. And x plus 1 equals 0 is x equal to negative 1. All right. Let's write down my solutions. Okay. So my first answer, I'm going to write it down as 0. I know I'm not doing it in numerical order. That's fine. I'm going to write down 0. What's the multiplicity on 0? So yeah, it's 1, right? Look where it came from. This came from here. This was up here, the x to the first. But remember, we don't write multiplicity once, so we're not going to do that. My next answer is 2. 2 came from x minus 2. And the power on x minus 2 is what? 2. So this is multiplicity 2. That means that answer pops up 2 times if you were to solve it completely. Okay? And then my last answer is negative 1. And what's the multiplicity on that one? 4, right? Because that's the power where it came from, okay? Right here. All right, are we good with that? That one? So, 4, 5, 6, 7, yeah. So this is how you would do it if it was an equation that's factored for you. So there's going to be stuff like that, okay? There's going to be some questions on your homework that say, like, if it's even multiplicity, does it bounce or go through? So we already talked about that right here when we said, like, it's going to bounce or go through, right? Like in the middle area, right? And then there's going to be some questions. Well, let me write this because this is going to be the next one, okay? And that's the last one. But where are zeros found on a graph? So this is more of a reminder. Where did we say we find them when we look at a picture? On the x-axis, right? So I'm going to put right here, look at the x-axis. So this is just a real quick reminder. All right? So it's just a real quick reminder. Now, another real quick reminder. If it goes through, then it's odd multiplicity. If it bounces off, then it's even multiplicity. Now you already have this written down, just so you know. You don't have to write it down. All of the stuff I just wrote, I've written down already. But I wanted to revisit it right before we do a graphing problem. Okay? But everything that we just wrote down and read, we've done before. So we know that if it goes through, it's odd. If it bounces off, it's even. And you're going to focus on the x-axis. Okay? Focus on the x-axis. So here's our last example. And I got 10 minutes, so I think we're good. Let me give you a little bit of time. Now, I'll let you guys write this down, and then I'll start recording again. All right, so for part A, how many zeros does it have? We already said it has 4 zeros, right? It has 4 zeros, 4 solutions, 4 roots, 4 answers, right? We have 4 of them. Okay? Now, what are those solutions? I'm just going to kind of write them really quick. negative 2, negative 1, 2, and 3. But that's not their multiplicity included. I got to include their multiplicity. Okay? But those are my 4 zeros right there. Now, part B, let me just put B right here, ask me the following questions. Which zeros have even multiplicity, and which ones have odd multiplicity? So let's talk about the even ones. Which ones are even? The negative 2, how do you know? Because if you look at the graph, look, it bounced back, right? It didn't go through, it bounced back. So negative 2 is one of them. What's the other even multiplicity? Positive 2, right here, because right here it bounces off, right? So I'm going to say 2 it has even multiplicity. And negative 2 has even multiplicity. All right. What about negative 1? That's odd. And I know it's odd because notice it goes through the graph, right? It didn't bounce off of it. It kept going through the x-axis. It didn't like get repelled by it and go back the other way. Okay? So negative 1 has it. What's the other answer that has odd multiplicity? 3. So there we go. So negative 1 has odd multiplicity, and 3 has odd multiplicity. Now I know I didn't ask you to do this in the problem, but if I were to kind of look at this, you should be able to, like I said, given a function that we have right here, this picture, you should be able to tell where it's even and odd multiplicities, right? By looking at the picture. You should be able to figure out what its solutions are just by looking at a picture. Okay? So our solutions are negative 2, negative 1, 2, and 3. Don't worry about how high it went and how low it went on the valleys and the highs and stuff. Don't worry about that stuff. Just look at the x-axis. Okay? Focus on that. Your homework today is basically this.